Whenever you are asked to work out a stationary point, you know that you need to find dy by dx and make it equal 0. So in order to do that for this equation here, we need to simplify it and make it a little bit easier to work with. So what I'm going to do is multiply out the brackets first. Then work out dy by dx. Make it equal to 0 and solve to get x. So here what I can do is take out common factor, which is 3x to the half, and then I'm left with that. So this means that x equals 0 is one of my solutions, and this bracket gives me the other one. So I need to do 64 to the power 2 over 3 to get x here, which is 16. Okay, so we are told that x has to be greater than 0, which means I can just ignore that solution. And I only have the 1, which is 16. But it needs to be in the form 2 to the power something. So if I just rewrite 16 as 2 to the power 4, then I know alpha equals 4. To work out beta, I need to work out the y coordinate for this x coordinate. So I need to sub x equals 2 to the 4 back into my original equation. And I get 2 to the 4 bracket, that's going to become 2 to the 8. And then we've got 128, which is 2 to the power 7. And root x would be 2 to the power 2. So I've got 2 to the power 4, 2 to the power 8, and then 2 to the 7 times 2 to the 2 would just be 2 to the 9. And 2 to the 8 minus 2 to the 9 is minus 2 to the 8. So again, when you have two numbers with the same base number timesing each other, you can just add the indices together. So we've got minus 2 to the power 12. I kept everything in the form 2 to the power something because I know that that's how they want my answer to be. But if you're uncomfortable with that, you can just plug it into the calculator, and when you get your answer, work out what power of 2 that is. Okay, the next part says justify that the stationary point is a local minimum. So what we do to figure out whether it's a minimum, maximum, or point of inflection is we double differentiate. So I need to differentiate this equation here, and I end up with 6x minus 96x to the minus a half. We then sub in our x value, and we end up with 96, take away 24, which is 72, which is positive. Therefore, it must be a local minimum. If it had ended up being negative, then we would have known it was a local maximum.